So the first example that I want to quickly talk about is this. It says find the resultant of a vector and direction given the following vectors A and B. As you can see here, A is given as 3 kilometers and then B is given as 4 kilometers, and then we are looking for C. The formula for finding the resultant vector, the magnitude of a resultant vector C, is given as A squared plus B squared. So if you plug in 3 for A and 4 for B, you have square root of 9 plus 16, that gives you square root of 25, and then you have 5 kilometers. So the magnitude of the resultant C is 5 kilometers. Then the next thing you want to do is to find the direction. The direction given as theta, and tan theta is usually given as a vertical component of the vector divided by the horizontal component. So you can say tan theta is equal to B over A. Find out that your theta is equal to tan inverse of B over A. In this case, B is 4, A is 3, so our theta will be equal to 53 degrees if you use your 4-figure table or you use the calculator to find it out. So if you represent that on an XY plane, what you have is you have your B on the vertical axis, your A on the horizontal axis. The direction, which is 53 degrees from the horizontal, you can see here that the particle is moving in this direction, 53 degrees from horizontal and moving this way, and then this is the vector eventually of the particle. That sums it up for this particular question. The second example says find the magnitude and direction given the following change in x and change in y. And this pretty much looks like the first example that we solved. So given that change in x is minus 1.78 kilometers and then change in y is 2.96 kilometers, find the magnitude, the delta, and the direction theta. So first of all, you might want to remember that our delta, which is equal to delta xi plus delta yj, this is like x component and this is y component. So combining these two components together gives us the entire component of the vector. Since we know our change in x is minus 1.78, our change in y, you can write them here, and then gives you the vector notation for the vector that we are looking for. Now, how do we find the magnitude of this vector? Components of x squared plus component of y squared, all in a square root. Don't forget, we could be asked to deal with 3 dimensions. In that case, we could have change in xi plus change in yj plus change in zk. But here, this is just 2 dimensions. Let's see how it goes. Now, magnitude of these vector will therefore be the horizontal component squared plus vertical component squared. Put everything in square root. If you do that, at the end of the day, you obtain 3.45 kilometers. Now, we want to find our angle theta. There are 2 thetas here that we are going to obtain. The first theta is theta equal to tan inverse of change in y divided by change in x. We always put the vertical component right on top here divided by the horizontal component. So if you do that, you find out you have theta will be equal to minus 59 degrees. So as you can see here, this minus 59 degrees simply means that the particle we're talking about is on negative x-axis. The vector is making an angle of 59 degrees on the negative horizontal axis. This is very, very important. Okay, so if you want to find the theta from the origin, starting from the beginning, from the positive x-axis, all you need to do is to subtract this theta prime from 180 degrees, and then you have 121 degrees. So that sums it up for this particular question. If you have the time, I would like you to go and find out what tan minus 59 degree is. Also find out what tan 121 degrees is. You will pretty much discover that they will be the same. The third example on our vector topic, a car travels from point O through checkpoints A, B, and C. Via checkpoint A, it traveled 36 kilometers due east. Via checkpoint B, it traveled 45 kilometers due north. And then via checkpoint C, it traveled 25 kilometers northwest. Find the magnitude and the angle of displacement of the car. Don't forget, if you need more clarifications on any of these questions and solutions, please, you can ask me in the comment section. I will make sure I look at all the comments and I'll respond to them accordingly. So please don't hesitate to do that. And if you know other students who need to go through these materials as you are going through it and you think this will be helpful for them, share with them and let them know they need to subscribe so they can get more updates of all these solutions and questions and topics that we discuss on this channel. So the first thing I would like us to do is to try to represent this question on an XY plane. XY coordinate. Okay, first of all, you do know that our Y axis is vertical, our X axis is horizontal. So they told us that the car moved or traveled from point O through point A, B and C. So if this is point O from the origin here, we represent that as the origin, and then it moved to checkpoint A due east. You know from our cardinal point that the north is always right up here, the east is always somewhere here, the south is somewhere at the bottom here, and then the west is somewhere on the left axis of the east. So if they say checkpoint A 36 kilometers due east, we want to say that first of all, the car moved in this direction due east, according to what we have here, 36 kilometers. So that's how we represent vector A, or the movement A. Also, from this particular point, we were told that it moved to checkpoint B, 45 kilometers due north. So from here, our due north will right, vertical upward, vertical upward. That's going to be 45 kilometers, and this is going to represent our B. And then checkpoint C, they said due northwest. Now, this is very important. Whenever you hear the term northwest and no specific angle is given, what you assume is that northwest will be 45 degrees between the north and the west. We have 25 kilometers due northwest. So from this particular point, if you have our cardinal point drawn like this, northwest will be somewhere between our north and the west. So we draw the movement of checkpoint C, 45 degrees from B to this direction. All right, so we have 25 kilometers, and then we have from B to checkpoint C here. The car traveled from O to A, and then to B, and then to C. 36 kilometers due on A, 36 kilometers to A, 45 kilometers to B, and then 25 kilometers to C. What you want to do here is that you will draw from the stop. This is where the car stopped. So from this point where the car stopped to the point where the car started, you're going to draw an imaginary line to connect those 2 points together to tell us that this is going to represent the displacement of the car from the starting point through A, through B to C, where it stopped. So we represent that with D, and then the angle of displacement will be the angle he made when he started, the angle between the line he made when he started the journey and when he ended the journey. And so this is going to be the angle of displacement here, called theta. What we are looking for in this question is this magnitude of D, this D, and then we are also looking for this angle of displacement theta. All right, let's take it a step further. To find our D, you notice that we have 3 main movements here. Okay, each of these movements would have their respective horizontal components and vertical component. So for the total horizontal component for this journey will be dx, and the total vertical component will be dy. So first, let's find the total horizontal component for the journey traveled by the car. So that will be given as dx. It will be equal to the horizontal component of A plus the horizontal component of B plus the horizontal component of C. So what is the horizontal component of A? It has been given that the car moved from 0 to 8. That will just be 36 kilometers. So you put 36 here. The horizontal component of B would be 0. The reason horizontal component of B is 0 is because this is vertical. This is totally vertical at 90 degrees. There is no horizontal component. If there's going to be horizontal component, it's going to be 45 kilometers multiplied by cos 90, and we all know that cos 90 is 0. Okay, so automatically the horizontal component for B would be 0. Anytime you are given a vector like this, or a movement like this, or a motion like this, and then you have this is at 90 degrees, the horizontal component will always be 0. And whenever you have a horizontal component without any special angle at 180 degrees, of course, you know the vertical component certainly is going to be 0. But let's move on here first. So we have AX plus BX plus C. This is 36. We explained that this is 0. And then our CX. What is the horizontal component here? So from what you can see here, this is not totally vertical. B to C is not totally vertical. It's not totally horizontal. So in this particular case, we have to make some conversion. What we do is, if you remember from the previous video where we talked about vectors and their components, if you want to find the horizontal component of a vector, it's given as that vector, which is 25 in this case, multiplied by cos of the angle that it makes with its horizontal. All right, now from what you can see here, this angle made with the horizontal, it's making this angle with the negative horizontal axis. So here, instead of writing plus, you put negative here, and then the vector is 25. The magnitude of the vector here is 25 cos 45 here, which is the angle it makes with the horizontal. If you multiply all these and add them together, you have dx is equal to 18.3 kilometers. Now you hold that somewhere, keep it somewhere, and then we go ahead and find our dy. How do we obtain our dy? We're going to use the same method to find our dy. Dy represents the total vertical component of the entire journey. So dy will be equal to ay plus by plus cy. All right. For movement from O to A, the vertical component ay will definitely be 0, like we explained the other time. And then for B, the vertical component automatically is 45, because we were told from what we analyzed, the journey is vertical and it's 45 kilometers. So you put it's entirely vertical, mixing an angle of 90 degrees with the horizontal. Okay, we have by to be 45 kilometers. We put that here, and then our cy also here. This is not entirely horizontal, it's not entirely vertical, so that means we can always find the vertical component different from what we already have represented in this diagram. So that would be, if you remember also from the previous video that we made on vectors and their components, to find the vertical component, it will that vector multiplied by sine of the angle the vector makes with the horizontal. All right, so from what we have here, you can see the magnitude is 25, or the vector is 25, sine 45 degrees. From what you can see here, we are in the region of positive y-axis to the top, and the negative y-axis is to the bottom. Okay, we are right in the positive y-axis, so this remains positive, and then we have 25 sine 45 degrees here. If you multiply all these out, you obtain dy equal to 62.7 kilometers. From what you can see here, we have our dx and we have our dy. So what next do? We can represent this in the vector notation by saying the vector d will therefore be dxi plus dyj, and that will give us 18.3i. From what we obtained here, our dx is 18.3i plus our dy is 62.7. We have 62.7j here. So this is the vector notation for the displacement. The magnitude of the displacement equal to the horizontal component squared plus the vertical component squared. Put everything in square root. We have them as 18.3 squared plus 62.7 squared. If you put them in square root, you're going to obtain the magnitude of the vector d. If you do that, what we do have is magnitude of vector d equal to 65 kilometers. Now that solves the first problem. And then they asked us to go ahead and find the angle of displacement. Remember, we said that the angle of displacement is always equal to tan inverse of vertical component divided by the horizontal component. In this case, it is dy divided by dx. That gives us tan inverse of 62.7 divided by 18.3. So our theta will be 74 degrees. If you punch your calculators or use the 4-figure table, you will find the angle of displacement to be 74 degrees. I will solve more examples and more complex examples in the next video. Don't forget, if you do have any questions, any questions at all about what we have discussed, what we have talked about, don't hesitate to put those questions in the comment section. I'm going to check them. I'm going to try to answer all of those questions in the next video.